Dies are usually produced from hot work tool steels, mold steel, mar-aging steels, and to a lesser extent, refractory metals such as tungsten and molybdenum alloys. All tooling materials are noted for high hot strength and high temperature wear resistance. Dies are usually made by machining from blocks of wrought metal, but they also can be cast and machined. Because of their machined features, precision, and materials used, die casting tooling is expensive, but the dies are reusable for thousands or even hundreds of thousands of parts. The cover die half contains a port for entry of the molten metal from the metal injection system. The ejector die half usually contains the channels called runners through which the molten metal flows to reach the gate or gates at the die cavity. Dies are typically single cavity or multiple cavity dies. Multiple cavity dies are usually used for multiple identical parts. However, they also can be used to produce parts of different design, and if so, they are commonly called combination dies. Because such dies are often used to cast parts that will be assembled together, they are also called family dies, meaning dies for a family of parts. Cores, fixed or movable in either die half, are used to cast holes in various directions. Fixed cores are in line with the direction in which the die halves open. Those for holes in other directions are retractable on moving slides, also called core pulls, to move in and out with each shot. Inserts, placed in position before each shot, also can be used to cast complex features, or to be cast in place as an integral casting feature. To minimize porosity in the casting, the die halves have vents to release the air that is pushed ahead of the metal shot. Overflow channels in the die blocks catch surplus metal. They also assist in venting and provide locations off the casting for its ejection. Built into the die blocks are cooling lines, circulating water or oil to dissipate the heat of the molten metal at a precise rate. Cooling at a controllable coolant flow rate is important because it controls the metal solidification rate. An ejector system is required to release the casting. In the system, ejector pins are mounted between ejector plates in a pocket on the ejector side of the die. In most cases, they are activated by pneumatic or hydraulic cylinders. To facilitate casting ejection, dies and cores incorporate a slight draft or taper, the amount depending on the metal to be cast. In general, the lower the metal's melting temperature, the less the draft required.